Welcome to our video about Omniverse Kit SDK. In this video, we will review the high-level concept of building applications using Omniverse Kit and how to get started. Omniverse is a platform to simulate reality. It's connected with many of the applications that are used in the various industries. It uses the Nucleus server to bring collaboration to the platform. Kit is a toolkit built on USD to create apps to solve your problem. For example, build robotic editor, scenario editor for self-driving car. It uses Python for scriptings and has a core in C++ for efficiency. You benefit from all our great technology at NVIDIA, from AI to VR and physics that are bringing to the simulation platform. They include a state-of-the-art renderer, real-time, fully ray trace, multi-node, multi-GPU to take advantage of our tech. Here is a quick overview of the stack for Omniverse Kit. At the bottom, you can see what comes directly with Kit. That include many SDK to do physics, rendering, compute graph, and many more. All of those coordinate the data that is natively stored and manipulated using USD. Above that, you have access to many core extensions we are building to augment the platform. Finally, at the top, you can see the Omniverse Apps. They are composed using those building blocks into purpose-focused apps. You, of course, can bring your own code and build extensions to put into the mix. To make it all this less abstract, I thought I would go over an Omniverse app and show you how it's constructed. This is Omniverse Create. It is an Omniverse app for content creation that was used to assemble the Marble RTX demo that hopefully you've all seen by now. It contained the general functionality that you would expect from an application of that type, but it is not built as a monolithic application. Let me show you how. Instead of being one application, it is made of extensions. Those extensions are killed building blocks that you can assemble in many ways to create different types of app. At the higher level, they are all written in Python to assemble the UI, the workflow, and the general feature set. When required, or for performance reasons, or to access some C++ API, C++ plugin can be added to the extensions, and we use binding to connect with the UI. Those extensions also include their icons, images, configurations, all they need to run individually. Let's go over some of the core ones now. The RTX viewport extension. It leverages Omniverse RTX renderer to provide an incredibly beautiful view on your data, leveraging all of the RTX technologies from NVIDIA's GPUs. It is scalable from real-time, even on large scenes, and accurate using ray tracing or eye tracing mode. It leverages MDL materials to be physically accurate. The geometry are read directly from USD, and your assets require no modification to render in real time. The Omniverse Content Browser extension. It provides a great way to browse your Omniverse Nucleus server, organize your data, and find the files you want to work or collaborate on. Alongside showing your Omniverse servers, it also works with all of your local data, so you don't always need to be connected to work. There is a rich set of API that enable you to add your own actions to the files. Powered by deep tag, the Omniverse servers are searchable in new ways using AI classifications. But this too is modular based on extension. Again, build entirely in Python means that you have full access to its source code. You can use it to learn and build your own, connect with your own servers, add new file types or icons. Also, it is not itself monolithic. A core principle of Kit is extreme modularity. So we always look for opportunity to build small building blocks that we can reuse. Here, you can leverage the Nucleus file path fields, the file grids, or this tree view independently and use them into your own extensions. Even the search is added as a separated extension connected to the Nucleus AI indexing services. We have a great collection of USD widget and window extensions that you can use to work with your data. The Stage Window extension leverages the Stage Widget extension to build a rich browsing experience of your stage data. The Stage Window contains all of the information on the object in the scenes that enable you to manipulate them. The Property Window provides you access with all of the information on the object's attributes and the various information about USD. It is also fully extensible, and all of the sections into it come from dedicated extensions that are targeted toward different primitive types, and then you can build your own. Finally, the layer window gives you access to a powerful layering system that USD provide for rich compositions. But it's also a great place to find Omniverse feature around layer management and live collaboration. Ultimately, all that you see in Create and other Omniverse apps come from extensions. They are the atomic building block of the Omniverse apps. Here are some examples I picked to give you a sense of the things that you can leverage into your apps, but also use them as example for extensions that you want to build. As again, all of those are written primarily in Python, so you have full source access. On the left to right, a toolbar example that we use to manipulate the USD scenes. Context menu frameworks for you to build your own context menu. Profiling data that shows you what's going on in your scenes and the performance you're seeing. UI for picking dates, a great graph framework that we'll talk a little bit later into the presentations. Here's an example of Movie Maker, so you can capture great cinematics of your scenes. Even the menu bar is customizable and extensible for your own needs. This is just a small set of what we are working on to share with you for our beta release of Omniverse Kit. Let's do a recap about the Kit extensions. They represent the building blocks of any Kit applications. In the system, almost everything is an extension. They are version control, so you can load different versions at different times. They can depend on other extensions, so you can build complex tree of extensions and then have the right behaviors happening automatically. They're also hot reloadable, which is really great for development, as we see in some of our other presentations. With Kit, we provide a great extension manager. The extension manager enables you to browse all of the extensions in your system. For there, you can see their different names and their properties. You can search for them. And for each extension, you get detailed information on its dependency, its changelog, and some of its important properties. The extension manager is a great place for you to start discovering applications other people have made. You can find their source and their descriptions inside these applications, and so you can start using them to build your own. Here we have a large collection of extensions. The viewport, the graph view, the stage and layer windows, and many more. Scripting engines, the documentation is showing there. Your app is really ready to get some users. Let's talk a little bit about our UI system, Omniverse UI. When we started the project, we wanted to have a really fast, hardware-accelerated UI that would be lightweight and open. We based our framework initially on the Dear IMGUI library. Some of the key features that we're going after is to have a modern, fast, and lightweight UI framework. It is the foundation of the Omniverse Kit user interface. We wanted our UI to be declarative and have very dynamic layout. It has to be fully stylable, using HTML-like style sheet workflows. We also have implementations for featuring UI streaming with lowest UI qualities, and then are working on XR, VR and AR rendering to project those widgets into the 3D worlds. In terms of platform, we are supporting full C++ and Python using bindings, and eventually potentially other languages. We support Linux and Windows. And for those, we have DirectX and Vulkan, and then Vulkan's on Windows and Linux. We have other platform plans, like on Mac or ARMS in the planning. Here's what the stack looks like. We already discussed about Dear IMGUI being one of the pieces. At the lower level, the graphics API. We have level of abstractions for graphics, input, and windowing that enable us to be cross-platform and cross-rendering API. And then on the top, we're building our OmniUI C++ library to enrich all of these IMGUI widgets. And all of those are Python binded, so you can interact with them completely in Python, leveraging the full speed of the C++ API. You get access to a rich documentations. These extensions, Omniverse UI documentations, is built entirely as a Kit applications using OmniUI as the widgets. There's no HTML or other language here. Everything here that you see is OmniUI. It enables for fully interactive documentations where all of the buttons and sliders and images do the things they do in your app, but also represent an incredible sample for you to look at how to build these things. And so whenever you see something in the documentation that you like, there's a source file that includes the entire Python code that will let you know how to do that. Okay, let's talk a little bit about the UI declarative syntax. Here on the left, you see the code, and on the right, the window it generated. I want to kind of highlight a couple of really interesting items there. We dynamically declare on the stacks, those stacks, so they're easily sort of seen. Probably something that you've seen in Swift UI or maybe just HTML. So with the vertical stacks, then we go into the next block. We create a Z stack, so we have layers in depth of stacks where we can create an image. Here, this splash screen, and then I've layered it on top of it with a UI label to put this little create label. And then I've used a placer that enables you to place items anywhere. And those placers have loads of interesting features around being draggable, and so you can build really rich and interactive UI. You put spacer. There's different types of spacer that could sort of be dynamics. As we go down, we have the stylable widget. So here we're creating this simple declarative UI label, and then we make a font size of 18. The styles are cascade, like in styling sheets, so they could come from the base classes and they could go down to your UI. Again, a separator, an horizontal stack, so H stack, horizontal stack with 2 buttons. And here we see the simple single line declarations where none of these variables have to be captured. UI buttons, name of the buttons, some actions. That's it. That's all you need for a button. And if you want some style, you say UI button, style, and then you add a style, some background color, and here some label colors. So if you go down, you have these model-based widgets. So sliders and fields and all these things, they're built on models. They enable you to have really rich binding between your data and then the sliders. And then here some more advanced UI. Here we see again a UI that has a little bit of a data provider, so it built dynamically. So 20, 30 lines of code on the left, and then a full rich window on the right. All of these, again, fully auto-reloadable. When I build that samples, I just move things around, press enters, and this image recreates itself constantly. So really interactive experience for you. Here's some documentation from the styles. Just want to highlight that the style sheet is very, very flexible. It's really similar to what you'd seen in something like HTML. You create your styles, they will cascade through the stacks and the layouts, and they can really enable you to do loads of different things. They have style for hover and click and enabled, and then different types of styling. So they really provide you a rich way to make your applications be very unique, and also it's very quick to do some simple coloring and styling for your items. So you really have a good place to start on working with your designer to build incredibly beautiful apps. Here is an example internally where we really sort of use that to the maximum. The team that built the View app, built on Kit, wanted to have a more sort of look that matched the AEC experience, and so they wanted to be more like white and these buttons and color. So work with the designer, and then they have a distinctive looks where they could use the styling sheets and Omni UI to build very rich and distinct experience for their customers in the app. Some example here where just to show a breadth of the type of widget that you have, but everything that you'd see, but again, they're really simple to instantiate it. You have Dropbox, you have sliders, you have fields that can be draggable. Again, here we see the different styling that are applied to these labels or these different things. You have, of course, collapsible frames, color picker, all of these really easy, entirely built in Python, again, available in the samples, so you can pick them up and go from there. There's a really great tree view. It serves as a tree view, but you can use it for list view as well, and table view. And so it's a very flexible system that use an abstraction of model view controller. So you have your model, so you can write your own model that binds to your data. To here, see, we show the stage, but you could show any types of lists or trees. And then you have a full control over the look of these widgets. So it's not really just other widget can have an icon and a label, and you have a fixed number of columns or things like that. It's very much programmable, where every single cell in that table will have callbacks that enable you to create anything. These widgets can have sliders, they can have buttons, images, anything you like, really. You're in charge of creating what's the look of these cells. So very flexible, very fast. We use it to do search and display very large number of items. We have a really great graph framework. And again, here, the extreme modularity of our platform was really a key design principle. The entirety of the graph framework extensions that is available in Kit is written in Python. So you have full source access, you can look at it, you can hack it, you can improve it, do anything you like with it. You really have a full access to it. Here are a couple of examples of the things that we're using it internally. On the left side, you see that Misty demo that we've seen in some of our GTC demo. That's the brain of Misty using the OmniGraph and then the UI to represent these nodes. On the right-hand side is some of our designs around building material graphs and MDL editors. And at the bottom, some of our proceduralism around compute graph. One really interesting aspect of the graph networks is it has two really interesting API entry points. It's a kind of I call it bring your own model and look. So the graph framework is around coordinating the nodes, providing you a platform for all of the things that you'd need to do using graph framework that are generic, and then simple API to use, again in Python, to implement your own model. So the backend, what's your nodes? Where's the list of nodes? What's their name? What's their children's? How they're connected? All of these informations really belong to the type of graph that you want to build. So you have models, abstract models that you implement, and then you bring your own model into the graph system. There is a default look. That's the look that we've seen into the previous slides for the node. But here again, you have full flexibility to write programmable on the look. So here, I just want to show a little bit of how that's structured. The nodes themselves are templated nodes with entry points. So you have a node background, you have a node header, you have node ports, you have a node footer. Each of those can have plugs on the sides where you can connect different types of informations. All of those virtual functions that are have a base class implemented, that we provide a default look that you can use directly if you don't need, or just use as a reference to build your own. Again, it's fully in Python, so it's completely accessible. And then because all of those are these functions, you can start doing really interesting things where you can only implement some of them. So here on the left-hand side, we see some example where only the header and a single port were implemented. So you have these standalone widgets. You see some where the headers is being enriched with an image preview. You can see some where the ports actually have widgets in them. And all of those, although they're built and set up in Python, they're rendered using this really fast hardware accelerated rendering backend. And so they can render a large amount of nodes at really fast performance without any speed delay. Here I wanted to show some of the example of some of the research that we did initially. There's a lot of nodes in the industry, and many of them really beautiful. Here the Autodesk Bifrost one, the latest from Maya. Really beautiful design, nice nodes. And so we wanted to see, hey, can our framework enable you to replicate that type of structure? And so we see on the right-hand side, OmniGraph, Python definitions, describing those nodes, showing how to kind of create the label and the color and the placement of some of these things to replicate the design that was given for the Autodesk. We then ask our designer to work on some interesting design that would be unique and specific to our application platform. So we see at the bottom left this design from Adobe XD. Photoshop, XD, whatever, like the flexibility is there that the designer creates their own look. They decide where they want to put things. They obviously have some constraints because of their nodes, but very few. And then on the right-hand side, that's the implementations of this design in code directly into these delegates that are transforming the different function calls into UI elements. And then we could able to do a really close one-for-one match into those. And then again, bring that flexibility that this code could be different per nodes and very programmable. Okay, let's discuss a little bit about building microservices using Omniverse Kit. There's really two main ways to build microservices using Kit. First, the nucleus-based microservices. Nucleus represents a coordination point in between a lot of different applications. All of these applications can, in real time, collaborate into the data, modifying it from different places. So every users can change the different pieces at the time. And then you can integrate in that flow Kit applications, and we discuss how they can be created headless with users or no using any of these extensions that you've made available that will in real time modify this data as well. So in that sense, a Kit application connected to Nucleus using the live synchronizations become a microservices of that ecosystem. And then you have the rich power of building apps that can contribute to that. The other ways that you can build is, we've also seen that Kit could be a very lightweight, small runtime, effectively, not very dissimilar to Python. And it's a small thing that will run apps. And then we can leverage that, including a control port layer that we've integrated inside an extension that will enable you to use, type of remote control behavior using HTTP or sockets or any type of transport protocol, and then connect directly into lightweight headless apps that can run in containers, be deployed in Kubernetes. They run on localhost as well. They use OpenAPI to be able to describe those API front end very easily and with all of the tooling from the industry. These control port extensions that ship with Kit is very simple, all written in Python. Of course, you've heard the themes by now, and it's sort of layered on top of open source technology to build a very simple ways to connect apps to a Kit microservices. Here on the left, we see what would happen into a Kit server, one of these apps that runs on Kubernetes, let's say, that expose some entry point. And then the extension would just say, give me the control port, register an entry point. So I want to register an entry point when someone call me with file copy, with some payload. I want to trigger some actions, Python functions, whichever that can leverage any of the features that are integrated inside the Kit SDK. We also have a small client in Python that leverage some of these things, but generally from any client, anywhere where you have Python, you are able to just import a request and make a simple HTTP request that will poke into that endpoint and then grab the data from a Kit running remotely. And so that enables you to really natively connect Kit in the server, running as a microservices on any type of infrastructure, and any type of client is able to connect to it remotely and then leverage its power. We've built internally really interesting microservices that extend this concept, because of course you're not limited to just run headless and with some of these CPU only microservices. You have the full access to what Kit can do in terms of leveraging the RTX rendering extension, PhysX, and many of our other AI simulations framework. And so you're able to generate large amount of data as a microservices deployed on clouds or farms. And it's been really, really interesting. And I think it will be really interesting to see what you can build with this functionality. Here again, there is a lot more to discover and learn about microservices. Make sure to watch the deep dive video we prepared for you. I want to discuss a little bit on how you have access to all of these SDKs using Omniverse Kit. We really bring all of the technology from NVIDIA and other places inside Kit so you can access them directly from your app. Of course, USD is fundamental to the applications. It represents your data. All of the data is stored in USD, and natively inside the application, this is the mechanism to modify it. It leverages an industry standards that has been beyond only media and entertainment, but has reached now automotive industries and other types of verticals in constructions and manufacturing. It represents a great, flexible, open format that we can all leverage to build applications that can talk with each other. Of course, we discussed many times of the RTX technology and the RTX viewport. It brings into your app an incredibly fast and scalable renderer. That means that you can render beautiful images of great complexity with many lights. Here an image of the Marble at Night cinematics that was shown a couple of months ago, all rendered inside Kit using the RTX viewport technology. But it's not just the RTX viewports that you can use. You can really use any viewport. At the core, we're leveraging Hydra, which is an abstractions on the viewport technology to communicate between USD and then the various renderer. Leveraging Hydra and the Hydra viewport, you can bring different types of renderer into Kit and contribute to this ecosystem. Here in that screenshot, I show the HD Storm GL renderer that comes with Pixar. But using the similar type of framework, you could bring the Hydra compatible renderer that is made for Arnold or Pixar RenderMan, or maybe your own in your company or the one that you've developed. And so you can bring your own rendering, and then you can contribute to the rich ecosystem of the other extensions via Hydra and USD for your data backend. In order to provide material definitions that are open and then supporting into many of these renderers, MDL was provided as an open source project by NVIDIA a few years ago. We continue to invest in that technology greatly for all our apps, and the RTX renderer fully leverage its power to build the physically accurate image that you've seen. We've also contributed the USD schema that enable you to represent these MDL file natively in USD, so they are able to be encapsulated into this file and moved from different renderer. And we constantly work with all of the different industry player, Material X and OSL, to consolidate to have an open shading format that enable us to work on great technology inside our app. And of course, we have all of the NVIDIA simulation SDKs that are being built and provided through the Omniverse Kit platform. Of course, PhysX, that provides you great, accurate, and fast physics simulations. Recently announced and shared with the general public audio to face, that incredible technology that converts audio signal into face shapes so you can have character talking automatically. A lot of simulations around fluids. Here we see some image from Flow, but we also contributed recently the Nano VDB framework that enable you to see large amount of volume data rendered in the GPU at incredible pace. And then a lot of work on AI pose estimations and different things that will come to be shared with you through the kit and the various SDKs. Now that you have all of these SDK, let's see some apps. Let's see some example of what was built using Omniverse Kit and those SDKs and those frameworks into something that is useful to the end users. Here, again, is back to the simple graph apps, and wanting to show you that you can build simple apps with few extensions. So here is an app that was built with graph extensions that we've written internally to share with other teams how to build graphs. It is just an extension for the graph, couple of small extensions for listing nodes and components, and it serves as a simple example that you can build from. Here is another example of a great app, the Isaac Sim app. It is built on top of the Kit SDK. Here we can see at the center that it leveraged the beautiful imagery that the RTX renderer is generating. It is built around USD for the data organizations and connections of these robots. It of course uses and connects to the Isaac simulation framework, and then is able to leverage all of the ecosystem of tooling in the Kit applications to provide a great app for our robotics community. View is one of these other great Kit app that we built and shared with the community not so long ago. It is built using the SDK and leverage this great customization that we talked about, using the Omniverse UI wheel styling to build really nice and unique interface. It leverages all of the connectors that bring the data from applications like Revit or Rhino into the Omniverse, and the RTX renderer to visualize in real time beautiful large-scale rendering environments. Audio to face that has been shared recently. Again, here we see the app streamline Kit experience that use few widgets, focus on showing the view of the character talking and be able to be represented there. Some of the informations, very focused app, few extensions, the power of the RTX renderer and the AI framework directly into your app. And then back to what we discussed at the beginning, Omniverse Create, of course, is built with the Kit SDK. It was, used to create the incredible Marble game and the Marble at Night rendering. Here we see it using a lot of these core extensions that we've built and used a lot to refine and perfect, so we can share them with you as building blocks that you can use your own apps. Of course, you can use Create to do incredible things and build art, but you can also use those different building blocks to then build your app. So here, I want to just try to complete a little bit that presentations with a recap on a few things that I really want you to take away with you. First, Omniverse is really built on a flexible extension system. At the core, it's building blocks that you assemble into apps that make sense for what you want to build and you want to create. We provide a rich set of extensions that is been production used and driven, that are served as example or building blocks ready to use for you to use in your own app, so you don't have to start from scratch. And finally, in that ecosystem, you get access to a large amount of SDKs that are really empowering you to build great physics apps, beautifully rendered apps, things with AI, renderings of fluids, work on AI simulations, pose estimations, and then all of these SDK come into life into Kit, for you to be able to use them in a really easy way and compose them into your app. I am really looking forward to seeing what you will build with Omniverse Kit.